Question 1. What is an atom? What are atoms made of? Answer. Atoms are the basic building blocks of ordinary matter. Atoms can join together to form molecules, which in turn form most of the objects around you. Atoms are composed of particles called protons, electrons and neutrons. Protons carry a positive electrical charge, electrons carry a negative electrical charge, and neutrons carry no electrical charge at all. The protons and neutrons cluster together in the central part of the atom, called the nucleus, and the electrons orbit the nucleus. A particular atom will have the same numbers of protons and electrons, and most atoms have at least as many neutrons as protons. Protons and neutrons are both composed of other particles called quarks and gluons. Protons contain 2 up quarks and 1 down quark, while neutrons contain 1 up quark and 2 down quarks. The gluons are responsible for binding the quarks to one another. Question 2. What is one example of indirect evidence that scientists use to study an atom? Answer. Pretty much everything we know about atoms is indirect evidence. One can't really see atoms. We do see enough of their effects that we can, with confidence, describe the nature of atoms. Here at Jefferson Lab we have quite a few instruments to measure the properties and behavior of atoms. We use a few simple tricks to measure atoms. The most common method is to shoot the atoms through an easy-to-ionize gas or liquid. Argon is the most common that we use. As the atoms or even pieces of atoms fly through the gas, electrons are stripped off of them and are left behind. We drift those loose electrons to a collection device, a wire or panel, and measure the charge. It is a little more complex than that, but it works well enough that we get consistent results. It's like putting together a puzzle that's missing some pieces. If you get enough pieces in the right place, you can tell what the picture is even though it still has holes. Question 3. What is an element? How many elements are there? Answer. An element is a substance that is made entirely from one type of atom. For example, the element hydrogen is made from atoms containing a single proton and a single electron. If you change the number of protons an atom has, you change the type of element it is. If you had very good eyes and could look at the atoms in a sample of hydrogen, you would notice that most of the hydrogen atoms would have no neutrons. Some of them would have 1 neutron and a few of them would have 2 neutrons. These different versions of hydrogen are called isotopes. All isotopes of a particular element have the same number of protons, but have a different number of neutrons. If you change the number of neutrons an atom has, you make an isotope of that element. Currently, scientists know of 118 different elements. Some, like gold, silver, copper and carbon, have been known for thousands of years. Others, such as meitnerium, darmstadtium and ununquadium, have only recently been created by scientists. All known elements are arranged on a chart called the periodic table of elements. Question 4. What is the simplest way of explaining what atoms, elements, compounds and mixtures are? Answer. Atoms are the smallest bits of ordinary matter and are made from particles called protons, which carry a positive electrical charge, neutrons, which carry no electrical charge, and electrons, which carry a negative electrical charge. The protons and neutrons cluster together in the central part of the atom, called the nucleus, and the electrons orbit the nucleus. A particular atom will have the same numbers of protons and electrons, and most atoms have at least as many neutrons as protons. An element is a substance that is made entirely from one type of atom. For example, the element hydrogen is made from atoms containing just 1 proton and 1 electron. If you had very good eyes and could look at the atoms in a sample of hydrogen, you would notice that most of the atoms have no neutrons. Some of them have 1 neutron and a few of them have 2 neutrons. These different versions of hydrogen are called isotopes. All isotopes of a particular element have the same number of protons, but can have different numbers of neutrons. Question 5. What is a mixture? Answer. A mixture is a substance made by combining 2 or more different materials in such a way that no chemical reaction occurs. A mixture can usually be separated back into its original components. Some examples of mixtures are a tossed salad, salt water and a mixed bag of M&M's candy. Question 6. What is the difference between a compound and a molecule? Answer. A molecule is formed when two or more atoms join together chemically. A compound is a molecule that contains at least two different elements. All compounds are molecules, but not all molecules are compounds. Molecular hydrogen, H2, molecular oxygen, O2, and molecular nitrogen, N2, are not compounds because each is composed of a single element. Water, H2O, carbon dioxide, CO2, and methane, CH4, are compounds because each is made from more than one element. The smallest bit of each of these substances would be referred to as a molecule. For example, a single molecule of molecular hydrogen is made from two atoms of hydrogen, while a single molecule of water is made from two atoms of hydrogen and one atom of oxygen. Question 7. I am not clear on what a molecule is. If water is a molecule, is it also a compound because the hydrogen and oxygen have been chemically combined? If so, how do you determine whether a substance is a compound or a molecule? Answer. A molecule is what you get when any atoms join together. A compound is what you get when atoms of two or more different elements join together. All compounds are molecules, but not all molecules are compounds. Water is a molecule because it is made from atoms that have been chemically combined. It is also a compound because the atoms that make water are not all the same. Some are oxygen and some are hydrogen. Oxygen in the atmosphere is a molecule because it is made from two atoms of oxygen. It is not a compound because it is made from atoms of only one element, oxygen. This type of molecule is called a diatomic molecule, a molecule made from two atoms of the same type. Question 8. How do atoms form? Answer. The current view is that atoms are made up of protons and neutrons, which in turn are made up of quarks and gluons and electrons. The protons and neutrons are at the central core called the nucleus, and the electrons revolve around it, being held in orbit by the electromagnetic force between the negatively charged electrons and the positively charged protons in the central nucleus. It is very much like the solar system with the sun at the center and the planets revolving around it. They were formed right after the Big Bang, when our known universe originated from pure energy some billions of years ago. The energy was converted to the elementary particles, quarks, gluons, leptons, etc., from which protons and neutrons were formed. From these, atoms of different elements were produced. Question 9. Does gravity affect atoms? Answer. Gravity affects atoms the same way it affects all other matter. Every atom creates its own gravitational field which attracts all other matter in the universe. If you put a lot of atoms together, like in a planet or a star, all of the little gravitational fields add together, creating a much stronger pull. If you could hold an atom in your hand and drop it, it would fall to the ground, just like a book or a brick. In fact, if you could remove all the air from a room and drop an atom in a vacuum, it would fall to the ground at exactly the same rate as a book or a brick would. After all, a book or a brick is nothing more than a collection of atoms. Question 10. Can you crush atoms? Answer. Not normally, but there are certain types of stars, called neutron stars, that are made from crushed atoms. The gravitational field is high enough in a neutron star that the electrons around an atom are forced to combine with the protons in the nucleus, creating neutrons. Imagine the sun squeezed into a sphere a few miles across. A teaspoonful of neutron star material would weigh several tons. Also, black holes are the ultimate example of crushed atoms. According to the math, the matter which makes a black hole takes up no space at all.